Okay, guys, today we are learning the power rule. We're learning an extra rule for our exponents. We've already talked about the product rule, where what do you do when you're multiplying two powers with the same base? We talked about the quotient rule, what to do when you're dividing two powers with the same base. This is called the power rule, where you're powering a rule, like powering a power to another power, which is bizarre, and you guys might not have a clue what to do with that at first, but we just have to break it down just like what we did with the other two rules. We're going to look at the expression, the expanded form, and the exponential form to figure out what is the rule that's happening with the base and between the exponents that's going to give us our exponential form, so that we don't always have to pull it out to expanded form. So when we're looking at our expression here, we have 5 squared raised to the third power. We're having a power and it's being raised up to another power. 5 squared, we know, is just 5 times 5. And what 5 squared to the third power is what we have here. We have 5 squared being multiplied times itself 1, 2, 3 times. 5 squared times itself 3 times. That's what 5 squared to the third power means. So we're going to go back through here and think, how many times is 5 actually being multiplied times itself? 1, 2, 3, 4, 5, 6. That's how we get the exponential form 5 to the 6th power. So we're going to look at -4 cubed raised to the third power, and we're going to see what happens with those exponents. -4 cubed just means you have -4 times -4 times -4. That means you're multiplying -4 times itself 3 times. If that is being cubed, if that's being raised to the third power, that means you have -4 times -4 times -4 times -4 times -4 times -4, and then that's multiplied times -4 times -4 times -4. So you can see I have -4 cubed multiplied 1, 2, 3 times together. And you're going to count again, how many times is that base actually being multiplied together within our expanded form? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So our exponential form would be -4 to the 9th power. We're going to look at one more. If we have x squared raised to the third power, well, x squared means x times x. If that's being raised to the third power, that means we have x times x times x times x times x times x. We have x squared being multiplied times itself 1, 2, 3 times. So how many times is x actually being multiplied here? 1, 2, 3, 4, 5, 6. So that means we would have x to the 6th power in exponential form. Now I'm getting ready to ask you guys to make your own conjecture, to make your own rule about what is happening here. Remember, what happens to our bases every time, even when we're using the product and the quotient rule? Do they change? Think about that when you're writing your conjecture. Also think about what is happening between your exponents in your expression to get us to the power that we have, the exponent that we have in our exponential form. What kind of operation has to happen between 2 and 3 in order for us to get 6? What kind of operation is happening between 3 and 3 in order for us to get 9? And again, what kind of operation is happening between this 2 and this 3 to get this 6 over here? So I want you all to come down here and pause the video, and I want you to make a conjecture. I want you to make a rule, an educated guess of a rule about what is happening when you take a power and raise it up to another power. What are you going to do with the base, and what are you going to do with those exponents? Go ahead and pause your video now. You should have already written a conjecture here when you pause the video. We learned in our other rules that when we are doing anything with these exponents, whether it's multiplying them together, whether it's dividing them, whether we're raising a power to another power, we always do the same thing with our base, and we're always going to keep the base every time. So every time we do this, the base is going to stay the same here. And then this time you should have noticed what is happening within those exponents. Well, with our exponents here, you should have recognized that in order for you to get 6, you'd have to multiply 2 times 3. 2 times 3 equals 6. In order for us to get 9 here with both 3 and 3, you would have to multiply, excuse me, 3 times 3. And again, with that third problem, our exponential form had a 6 for an exponent. In order to get that with a 2 and a 3, you would have to multiply the 2 times the 3. So our conjecture is that we keep the base when we're raising a power to another power, and this time we're going to multiply the exponents. So we're thinking about how can we set that up? How can we complete this expression to show that? All right. Well, it's just like what we said. If we have to keep the base every time, well, our base is an A. So we would have an A here as our base. And then show that we're multiplying m times n. And to show variables being multiplied together, we would just show that m n. Because anytime you see those variables squished together, that means they're being multiplied together. So a to the m power raised to the nth power would equal a to the mn power, where m and n are being multiplied together. So I want you to take just a couple minutes, and I want you to try these two out on your own. So we'll go over it, but go ahead and pause the video and try out. Do you have 2 to the 5th power? If you have 2 to the 5th power raised to the 2nd power, what are you going to do to get that exponential form? If you have -4 to the 5th power and that's being raised up to the 3rd power, what are you going to do to get that exponential form? So this time you should have tried out these expressions, this powering of the power using your power rule, and you should have done it without expanded form. So we think to ourselves, if our rule says that we are going to, if we have 2 to the 5th power and it's being raised up to the 2nd power, we have to think, what do we do with the base? Well, our rule says we've got to keep our base. And then what do we do with those exponents? Well, our rule said we need to multiply the exponents together. So that would be 5 times 2, which would give us 2 to the 10th power as our exponential form. When we're looking at -4 to the 5th power being raised up to the 3rd power here, we have to think, what do we do? Every time, we always keep that base, and we multiply the exponents when we have a power being raised to another power. 5 times 3 is 15. This would be your exponential form. Now we just have a little bit left here, and we need to think about this problem just a little bit more. If you have a negative number, what would your answer be? And I'm not talking about this because we've done this correctly. -4 is our base, and we're raising it to the 15th power because 5 times 3 is negative. But think about, would the answer to that problem be positive or negative? Go ahead and pause your video for a moment and figure out, would this be a negative number if you took it to standard form, or would this be a positive number? Did you all tell me that it depends on the exponent? Because if you did, you would be correct. If we have a negative number that's being powered up, well, if you had, let's say if it was -4 to the 4th power, right? that would be negative 4 times negative 4 times negative 4 times negative 4. Negative times a negative makes a positive, and then a negative times a negative, well, negative times a negative makes a positive number, and then that positive times a negative would be negative, but then that negative times a negative would make this a positive answer. However, if you just had negative 4 to the 5th power, negative 4 times negative 4 times negative 4 times negative 4 times negative 4, this would end up being a negative number because there's an odd number of negatives, and you don't have any negatives to cancel out and make positives. Negative 4 times negative 4 would be positive. That positive number times this negative 4 would be negative. That negative number times this negative 4 would make it positive, but then that positive number times that last negative would make that a negative number. So if a negative number is powered, the answer depends on the exponent. If the exponent is odd, the answer would be negative. Okay, so this is it. This is the end of our lesson here, and we're going to sum up what is the power rule. What do we do when we're powering the power? Our rule says when raising a power, raising a power to another power, you keep the base just like all the other rules and multiply the exponents. All right, guys. Ask me questions if you need to, but you need to get into the independent practice on your own. Thank you, guys.